like x plus y to the 0 is just 1. X plus y to the first is 1x plus 1y. And he said, I don't remember how to get the coefficients, but I know the exponents do this. X plus y squared is 1x squared, and I'll write it because he said it. The power of one starts at the high and the other one starts at the low. So x squared, y to the 0, x to the 1, y to the 1, dot, dot, dot. X plus y to the 5 equals x to the 5, y to the 0, x to the 4, y to the first, x to the third, y squared, x squared, y cubed. I lost one. 4, 3, 2, 1. Oh, x, y to the 4th, and y to the 5th. All that yuckiness. Okay, so you don't need to know this. Just I want you to see this for limit definition of derivative for x to the 5th, for example. So all that mess was supposed to be h's. So x to the 5th plus 5, x to the 4th h, plus 10x to the 3rd h squared, plus 10x to the 2nd h cubed, plus 5x to the h to the 4th, plus h to the 5th. So that's all f of x plus h minus f of x. All over h. Okay. Okay. You see it? This x to the 5th and that x to the 5th are going to go away. And then there's 1h, 2h, 3, 4, 5. I can factor 1 out of everybody and reduce. All of these are going to have another h in them. Now that one h was taken out, all the others have an h still left behind, right? So when I plug in that 0, the only thing that's going to come out is this, 5x to the 4th. So x to the 5th became 5x to the 4th. What if it was x to the 7th? What do you think that would be? Yeah.
7x to the 6th.
7x to the 6th. What if it was x to the 50th? I would not do this expansion.
50x to the 49.
50x to the 49. That's power rule. Like, it's always going to be by Pascal's triangle. It's going to create that coefficient, that front number is going to be the power. So this is power rule. Sorry, long way to get there. But what we're going to do is various kinds of power rule, and then we're going to practice product and quotient rule. We might get to these, we might not. Sorry, before power rule. Lily, pick a number.
7.
7. Alex, what is the slope of y equals 7?
0.
0. The slope of that horizontal line. This is saying the derivative of a constant. Derivative means how is things changing? How does a constant change? It's called a constant because it doesn't change. So the derivative of any constant is 0. Okay? So you don't need to write all the words around it, but maybe pick your favorite number. Oh, derivative of 7 is 0. the derivative of e to the pi is 0. I'll put that on the test sometimes, y'all get it wrong. You do power rule with it. Okay, ready for power rule, like formal? I'll show you how it looks from them, it's kind of gross. So power rule, multiply by the power, lower the power. That's all there is to power rule. And it's kind of from that binomial expansion stuff that we just did. And I'm going to like short circuit several of the next slides because I don't see these as a big difference. Milo, pick a number.
4.
Sam, pick a number.
5.
Alana?
30.
6.
Crazy number.
30.
It's not especially crazy. Unless you're planning on going crazy when you turn 30. That happens to some people. Okay. So to do the derivative of this trinomial, these three things, how do you think we're going to do that? Jeremy?
I think we're gonna use, well, it says if n is a positive integer.
N being the exponent, right?
Yeah, so I think we're just gonna do the power rule and get rid of, ignore the 30.
Okay, so what do you think?
So like 20 x to the 4th minus 18 x to the 5th.
And that 30 goes away because it was a constant. Yes. So there we go. That's the next couple of slides that I'm going to kind of speed over. If there's a coefficient on front, what do you do with it? Well, it was being multiplied to the x stuff. It still is. So when we lower the power, we're going to multiply it to that coefficient that was there. And the 30, negative 30, still goes away. But Jeremy pointed out positive integer. Positive and integer. What about that? Square root of x. It's not an integer. Can we still do the power rule?
Yeah.
Milo, what do you think?
Possibly because same as x to the 1/2.
So how do you think we would apply power rule as
Well,
your?
it's not a positive integer though.
It's not. I mean, it's positive, but it's not an integer. Can we still do power rule?
Yeah.
Yes, we can. So multiply by the power, lower the power. I know that this just says positive and it says integer, but it works with fractions. See from there? I keep standing in your way. So multiply by the power, lower the power. So the power was positive 1/2. So I'm going to multiply by that 1/2, and then x to the 1/2 minus 1 becomes negative 1/2. So that's why the square root moved downstairs. Good? You had a question?
Since the positive integer part is not true, does it also work for negative integers?
Okay, does it also work for negative integers? 3 over x. What is the power on x? Or negative 1. Multiply by the power, and then lower the power from negative 1 to negative 2. Be careful how you do that. The 1 was in the bottom of the denominator. It is a negative 1, but I just don't want you to write negative 2 there because that then moves it back up top. So not only does it work for positive numbers, they don't have to be integers and they don't have to be positive. Power rule works for all of those things.
Why does it say positive integer?
Because they want you to start off in baby steps and then on the next slide they're like, ooh, okay, This notation is written as a generalization for later. They're like, oh, any function of x, I'm gonna call it u, if it's got a constant on it, this is how you do the derivative. So if y is 3x squared, the derivative is multiply that constant by that power and then lower the power. So they're making it a separate rule, which you guys already did here. Like, it's not a super complicated thing and it extrapolates well. Okay, so let's see, what else did they, if you have two different lumpies, you do the derivative of this lumpy, and it was added before, okay, well, I'm gonna add, like, so, as Jeremy said a while ago, power roll this guy, plus or minus power roll that guy, plus or minus power roll, keep going. Does it have to be its own rule that you write down over again? Probably not. But your book does it over and over again. Let's check. Make sure you can do these. What's the derivative? Sorry, taking attendance. Sophia, what do we get?
I got 4x to the third plus 6x squared minus 3/4.
Where's 6x coming from?
Oh, sorry, I read that as a 3, not a 2.
Okay, all right, so,
So then it would be just be 4x
and then minus 3/4,
minus
and
3/4.
and the negative 19 goes away. Yeah, so, sorry, like the glare and this angle,
Yeah.
you guys are not at a good spot. So, you chose to sit there. All right, so just multiply by the power, lower the power, over and over. Cool. So, why do we have derivatives in the first place? Because often we want to find horizontal tangents. What does a horizontal tangent look like? Use this. So it's a flat horizontal line. Okay, so, and in calculus, we are obsessed with finding horizontal tangents. Why? Well, it's right here, it's right here, it's right here, it's right here. What do you notice about the spots where those horizontal tangents are? What?
Never mind.
They're about the same line level as each other?
Well,
No, they're not.
The slope is 0.
the slope is 0. Okay, let's say this is a business model for how much resources we put in, or what were you gonna say?
They're like the local maximums and minimums.
It's where all the highs and lows are gonna be. So the reason calculus is obsessed with it, if this is my business model for where I'm gonna make the most money by putting in resources, I'm gonna wanna find the high point and say, I'm gonna put in just that much resource to get the maximum stuff out for whatever I put in. And I'm gonna stop production when, I'm not gonna be Crocs and like over expand and go to China and like plummet because we overexpanded too much. Then that hits a low over here. Anyway, there are applications, it's coming up in chapter 4, but right here, find the horizontal tangents, the x values where the horizontal tangents of this graph would be. Yay, Milo. Woohoo! As Andy said, got a case of the Mondays, at least I do. I haven't quite heard it said so well. Daniel, what to do?
Wherever x is equal to, never mind. So we have, if we have derivatives, it would be wherever the derivative is equal to 0.
Okay, so what is the derivative?
In this case, it would be 4x to the third minus 16x. Yep.
Minus 16x, yep. And he said, Francesca, what do we do to find out where horizontal tangents are?
At the 0, so you can factor out an x and a 4. So one of the x's is equal to 0, and then the other x is equal to plus or minus 2.
Okay, so horizontal tangents means the slope is 0. So she took the slope that Daniel found, factored it and said, those zeros are gonna be, or those horizontal tangents are going to be at 0, -2, and +2. It's going to catch up right now. And they are. Reasonable? Okay. So now let's see. If I want to do the derivative of this product, the question's asking, is it the derivative of this times the derivative of that? Well, people are already shaking their heads like, no. Well, what is the derivative of x minus 5? 1. Multiplied by the power, lower the power. So the derivative of x is 1, and the -5 was a constant, so that's going to go to 0. Sam, what is the derivative of x plus 3? Also 1. Okay. Fine. Felipe, can you expand that, do the binomial FOIL expansion thing? For what is x minus 5 times x plus 3? Just doing algebra 1.
X squared minus 2x minus 15.
Paulo, what is the derivative of that stuff now?
2x.
2x minus 2.
So this is hoo-ha. You can't do the derivative of this and the derivative of that and multiply them together. It doesn't work. Okay. Well, there has to be a way. Here's the alphabet soup of this. Can you guys write it down and I'll show you with the example we just did. Random question. Does anybody know if they are colorblind? Because I often change colors and like the ones that show most starkly to me are like red and blue, but their color blindness is with that and red and green. So if you're seeing the same color, let me know. All right, so even when I was in high school, they used U and V, and if you're like me, sometimes U and V look like the same damn letter. I don't know why they do that, but they do. So It's trying to say, here's these two functions of x. So here's function 1, function 2. How we do the derivative of the two of those? First, untouched, times the derivative of the second. And Sam already told us on the previous page, the derivative of x plus 3, well, the derivative of x is 1. The derivative of that plus 3 just goes away. Okay, first times the derivative of the second, plus the second untouched, times the derivative of the first. Derivative of the first is also 1. Now those parentheses aren't doing anything, so x minus 5 plus x plus 3 is 2x minus 2. We get the same answer. Okay, and because I know it's coming, you guys are going to say, well, I'm just always going to distribute and like not have to know this rule. I don't recommend that, but I can and will ruin your day by making it something you can't. It's not a polynomial. We will have to do derivatives with sine, with log, with e. So you need to practice the rule anyway. So can you try it without expanding, but to do first times the derivative of the second plus second times the derivative of the first? Try it that way. What do you get?
I think you get 5x to the 4th.
Can you tell me one piece at a time, like how did you start?
Oh yeah, sure. So I left the first one, just like that, and then derivative of the second one is 2x plus the x squared plus 3, and then 3x squared, yeah.
Okay, perfect. And then distributing the little pieces, 2x to the 4th minus 8x plus 3x to the 4th plus 9x squared, combining like terms, 5x to the 4th plus 9x squared minus 8x, which I think is what you were starting to say in the beginning. First times the derivative of the second plus second times the derivative of the first. I cannot, it's not wrong to do it the alternative way, but I cannot do it. I can still see my high school calculus teacher doing this on board, and he said it every time for like the whole year. I can't. So when you guys do the second term first, it really upsets me. Just I can't do it. Good? Product rule. So what's next? Yeah. Party down. Quotient rule. Woohoo! Grossness. So I don't like it with U and V. Andy, you're giving it the stink eye. I write it with bottom and top. And the pattern is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And there's like a sing-songy thing that people say.
I've always just said like low D high minus high D low, but I'm not sure if that's like the actual like rhyme. It's like a hill.
Low D high minus high D low over low low, or low squared. I've had people rap this, I've had them do cheers with it, and like whatever. Some of them sang the opera, Valderie Valdera, with the low D high, high D low, over low low. I don't know. Do what you want to do. I don't sing, I don't rap, and I don't cheer. So if you've got a little sing-songy thing you want to share with us, by all means. Mr. Orlando, who used to teach this with me, all of his explanation of things are interpersonal relationships of things. So his story with this one is the one on the bottom is bored. So he wants to go visit, goes upstairs, and he's tired from the move. So the other one is like, fine, I'll do the derivative. And then he gets all cranky because I had to do the derivative. And me. So he gets all negative. And he goes back to his normal negative cranky self. And the bottom's like, fine, I'll do the derivative. And you're such a crank. And he goes back downstairs. You're to come up with your own story, Randy. So try it. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Sorry, they aren't grouped up. I would ask you guys to write your answers on the whiteboard. Does anyone have an answer to say? Yeah.
I got x to the 4th plus 9x squared plus 8x over x squared plus 3 squared. Or like all that squared.
Yep. Okay. Well, let's see if we agree. So f prime, bottom untouched times the derivative of the top minus the top untouched times the derivative of the bottom over the bottom squared. Oh, undo. Okay, distributing. Three x to the 4th plus 9x squared minus 2x to the 4th plus 8x over stuff squared, combining like terms. I get 1x to the 4th plus 9x squared plus 8x over stuff squared. All right, some comments on process. You need to keep the denominator every step of the way. Like in the cleaning up of the numerator, keep the denominator. Like it's wrong without it. And I will take off points on the next quiz if you lose the denominator and then it miraculously comes back later. Another thing, don't waste time expanding that. Because if anything, we're gonna be hopeful that, hey, maybe the final answer factors and reduces. This, we can take an x out, it's not gonna reduce, so it doesn't help. But you could factor it. And if this was an x cubed, not an x to the fourth, then more things would factor, but it still wouldn't help. But, good? So tonight's homework out of the textbook is practicing these. Notation, don't write it down, just look at it. And this is, okay. First derivative, y prime. Second derivative, y double prime. And they might write it like that. Okay, physics friends. If we have position, what's the first derivative of position?
Velocity.
Velocity, because that's your change in position over change in time, so that's velocity. What is your second derivative of position?
Acceleration.
So how is your velocity changing over time? So it's not a big deal, and I don't care if you write it wrong. It will make more sense when we get to chapter 10, but just to put some ideas in there now. This was change in position over time, which gave us velocity. However, the derivative of velocity, the change in velocity, it's not the same y value. So that's why the 2 moves in here. The second change of this now different function, the change in velocity over still miles per hour or miles per hour squared, feet per second squared, like that's still squared. We can do third derivative. Physics friends, what's the third derivative called?
Jerk.
Jerk. Don't be a triple derivative. Math humor. Yeah. We're never invited to parties. Okay. And when they get too big, which when we get to chapter 8, we will do 8 derivatives. They are hard to, there's none of this, like, that's the 12, no. They will do the parentheses 8. That means 8th derivative, okay? Once you get past 3, there's too many little slices up there and it gets to be a mess. So if they want the 4th derivative, what's the 4th derivative called? Snap, crackle, pop. Don't know why. Guess they liked cereal. Okay. Do all of the derivatives until it disappears. Can you see? Milo? Yeah? Really? What's the first exponent? 4. Okay. Checking. Derivative.
20x to the third minus 9x squared plus 4x minus 1.
Monica, what's the second derivative? 60x squared minus 18x plus 4. Okay. Evelyn, what's the third derivative?
120x minus 18.
Okay, if it would ever let me write.
Is that the same?
You said 120x minus 18?
Yeah.
Okay.
I would say prime number in my head. It's probably not like.
Third
Yeah.
Fourth derivative, Yoav?
120.
Got an easy one. Andy, last derivative?
I'm entirely sure.
Okay. What's the slope of that line that's y equals 100?
0.
So you just did 5 derivatives. You found if that was position, velocity, acceleration, jerk, and snap. And crackle. It's got 0 crackle. I believe so. Okay. Just real quick. Francesca, derivative of 0. What's the slope of this line that's y equals 0? 0. Ben, what's the slope of the line that's horizontal but down to?
0 also.
0 also. Eventually,
3.
Milo over there.
1/2.
Sam,
2.
Alana,
Minus 5.
Daniel.
-6x.
You wanted to say something else, but stop. Andy,
5,
multiply by the power, lower the power. So,
10x minus 2.
period. Done. You have number 12.
-4x plus 1.
Sophia,
Negative 6x squared.
Jeremy? Ooh, the hard one. No? Pass, call a friend. Felipe?
1 over square root of x.
Okay,
Negative.
multiply by the power, -1, and now lower the power from -1, -1, -2. Okay?
1 over x to the 3, and then I think there's probably a negative.
Okay, multiply by the power. What is the power?
-2.
Lower the power to -3, and I'm just gonna move it downstairs. Alex, square root of x?
It's just 1/2 x. Or root
One.
x. Over root x.
Yep, multiply by the power, lower the power. So 1/2 goes to x to the -1/2, all right? Pablo, 17. Multiply by the power, lower the power. So what's the power on there? 1/3. So multiply by 1/3, now lower the power. 1/3 minus 1,
Negative 2.
-2/3. So I'm not gonna write the negative, I'm just gonna move it downstairs. Ugh. Monica, 18. So multiply by the power, and now lower the power. So -1/2 minus 1, x to the -1/2 and minus 1, 3/2. Okay? Derivatized. Okay, that's all the things. What do you think? How do you feel? Oh, I need to give you back your test.